So there's this new technology out there that promises to do something amazing. Protect children by scanning our most personal devices. It sounds noble, right? But here's the thing. In this fight against evil, are we accidentally building a system that could end digital privacy as we know it? Let's really break down what's at stake here.
I mean, this really is the core of the whole thing. And you gotta understand, this isn't some hypothetical from a sci-fi movie. Nope, this is a real choice being debated by governments all over the world right now. It really forces us to ask ourselves, what price are we actually willing to pay for security?
Okay, so to really get our heads around what's going on, we're going to follow the whole story. First, we'll look at the privacy tech that kind of accidentally created this whole mess. Then, we'll dive into the super controversial solution being proposed. After that, we're going to expose its fatal flaws. And trust me, there are some big ones. And finally, we'll get into the global power struggle that is literally going to decide the future of our digital lives.
So, yeah, how did we even get here? Well, it all starts with a technology that was actually designed to protect us: encryption.
All right, let's talk about end-to-end encryption. You'll see it as E2EE. This stuff is like the bedrock of modern digital privacy. And the analogy here is just perfect. E2EE basically turns your message into a digital steel safe. The only people who have the key? You and the person you're talking to. That's it. Not the tech company, not your internet provider, not even the government can get in.
So you remember the Edward Snowden revelations back in 2013? Well, after that, everybody wanted one of those digital steel safes. The rush to adopt E2EE was a massive, massive win for our privacy. But it created a huge headache for law enforcement. They have this term for it, going dark. Why? Because their old school ability to just intercept criminal communications, poof, it pretty much vanished.
And that brings us to the proposed solution. It's a technology called client-side scanning, or CSS for short. And let me tell you, this represents a totally radical shift in how we even think about security.
And this quote just nails it. It perfectly captures the whole idea. See, CSS doesn't even try to break the encryption. That's not the goal. Instead, it basically puts a camera inside your device to scan your content before it gets locked in that digital safe. So yeah, the lock on the safe is still secure, but your privacy inside the room, it's just gone.
So this is the really crucial point, right here. Your phone, your laptop, your own personal device. It's no longer just a tool that serves you. It's been, like, deputized. It becomes an agent of surveillance, constantly policing everything you create and everything you share.
Okay, but how does this digital camera actually see anything? I mean, what's it looking for? Well, the answer lies in this clever but, and this is a big but, deeply flawed technology called perceptual hashing.
This chart does a brilliant job of showing the core issue. Okay, so a normal cryptographic hash, think of that like a perfect digital fingerprint. If you change even one single pixel in a photo, the entire fingerprint changes completely. But a perceptual hash, that's designed to be kind of fuzzy. It looks for images that are similar, not just identical. And right there, in that last row, that's where you see the fatal flaw: collision risk. So what's a collision? It's when the system creates the exact same fuzzy fingerprint for two totally different images. And get this isn't some rare bug. No, it's a mathematical certainty that is literally built into the design of the system.
And look, this isn't just some abstract theory. When Apple was developing its own scanning system, researchers found a wild example. A picture of a dog could generate the exact same digital fingerprint as a picture of a skier. Now just think about that for a second. Imagine the skier's fingerprint was on some banned list. All of a sudden, that cute photo of your family pet could trigger a red alert to the authorities. Yeah, that whole dog versus skier problem, that's just the tip of the iceberg. When you take this flawed technology and apply it at a global scale, well, the consequences become absolutely catastrophic. So what is this number 1 million? Well, check this out. Let's say a system scans 1 billion images a day, and let's say it's 99.9% accurate. That sounds amazing, right? But it would still generate 1 million false accusations every single day. That's 1 million innocent people who could be flagged as criminals, totally overwhelming any possible human review system.
And believe it or not, it actually gets worse. The system fails in two really critical ways. So, on one hand, actual criminals can easily bypass it. They just make tiny tweaks to an image, and boom, it's invisible to the scanner. But on the other hand, the system can be weaponized. An attacker could create a totally harmless-looking photo that shares a digital fingerprint with illegal stuff, basically using the system to frame anyone they want.
So with all these massive flaws, you might be wondering, Why are we still even talking about this? Well, it's because this isn't just a technical debate anymore. Not at all. It's a full-blown political battle.
You know, the most famous real-world test case for this was Apple. As you can see from this timeline, they announced a plan to start this kind of scanning back in 2021, and the global security community just erupted. They protested, pointing out all the huge flaws we've just been talking about. And by the end of 2022, Apple, one of the most powerful companies in the world, was forced to publicly back down and abandon the whole project.
But here's the twist. Where corporations retreat, governments often advance. As you can see right here, there are major legislative efforts in the European Union, the UK, and the United States that are trying to mandate this exact type of scanning. The fight that Apple thought it had won is now being fought in parliaments and congresses all around the globe.
And this brings us to the final and honestly the most important question of all. Once this massive surveillance infrastructure is built and put on all our devices, who gets to decide what it looks for?
You know, security experts have a name for this. They call it function creep. It starts like this. The system is built for a purpose pretty much everyone agrees on, right? Like fighting CSAM. But once that system is on billions of phones, the temptation to expand its use is just enormous. That same tool can be updated to scan for terrorist propaganda, then for copyrighted material. And then what's next? Political dissent? The technology, the infrastructure itself, it doesn't care what's on the ban list.
So ultimately what we're facing is a really stark choice. It's a fork in the road. Do we want our personal devices to serve us, the user, and keep our lives private by default? Or do we want them to serve the state, keeping us safe by monitoring us by default? Because the experts are pretty clear on this, you really can't have both. And if there's one thing you take away from all this, let it be this. The technology for a democratic safety tool is absolutely identical to the technology for an authoritarian surveillance tool. The only thing that changes is the list of things it's told to scan for. And that leaves us with one final really urgent question that we all need to answer. Once the camera's in the room, who gets to hold the remote?